All right, Algebra 2, I'm going to go ahead and do this lecture. I'm only going to do one video this morning, one, because of time, and two, because this is not that complicated. The main thing that matters on this stuff that we're doing, we're doing cubic functions and cube root functions. More or less, you can look at what's given to you right here. The cubic function is f of x equals x cubed, and when you plot it on a graph, that is what it's going to look like. So where do these numbers come from? If you take a look at the red dots, you can see the first one is if I plugged in a 0, and then I plugged it into there, 0 raised to the power of 3 is in fact 0. If I plug in a 1 into this, and I do 1 is to the power of 3, you'll get a 1. If I plug in a negative 1 down here, check it out. Negative 1 to the power of 3 looks like this. Looks like negative 1 times negative 1 times negative 1. Which actually comes out to negative 1. Because negative times negative cancels out into positive, but then another one gives you negative 1. So when you plug in a negative 1, you return a negative 1. And then if you go over here and plug in a 2, if you plug in a 2, you will get 8, and that's because 2 times 2 times 2 is 8. And if you plug in a negative 2, which is down here, you see your negative 2, all the way down to negative 8. So that's where your shape comes from. It basically derives from what you plug in there, and you can see this here. So you're in charge of knowing about this shape. You're in charge of knowing how, like, you see it, the 0, 0, the first two dots outside of it are just over 1, up 1, or this one is over 1, down 1. So you're kind of in charge of those shapes. Let's talk about the domain. The domain, actually, for these is the same. It is going to be all real numbers, and you can write that by going negative infinity to positive infinity. And how do I know that? Because even though these arrows are going up forever, and they are, it's also going to the right forever. So it's going to the right forever. And remember, domain deals with x values. So from left to right, you can see that it's kind of going on forever. It looks like it's not going down to the left forever, but it is moving slowly. So now, with range, this is also going to be negative infinity to infinity. And how can I know that? Because look at it. Read it from the bottom to the top. Where am I starting? Negative infinity. And where am I going when I'm going to the top? All the way to positive infinity. So these are the attributes. The domain is all real numbers. The range is all real numbers. There's exactly one y-intercept. There's exactly one x-intercept. And the graph has rotational symmetry about a point. Imagine a propeller. If you were to spin this graph around like a propeller, it would eventually match itself. So that's what rotational thing is. Imagine that's where it's spinning around the middle of the graph, and you can see that this arrow would be brought up and matched there. So that's what rotational symmetry is. Think propeller. Okay, so now we're going to talk about why I'm not going to do this very much. Y'all, we have done these transformations over and over, and it's the same rules. If it's with the x is going to lie. If it's with the x is going to lie. If it's outside of the x, like in these ones right here, it does not lie. So let's check it out. So in this one, this says x minus 4 cubed. What do I know about this? Because the x lies, it's going to move right 4. And what about this one? This one's going to move left 2. What about this one? It's not attached to the x. If it's attached to the x, it'll have the parentheses. So this is just talking about up-down movement. This one does not lie. This is up 3. This is down 5. So it's not that difficult to imagine how you would graph that, for instance. Let me go ahead and show you an example of that. If I had, hey, f of x equals x minus 1 cubed, that would mean move over 1. That means move to the right 1. So I would just move to the right 1, and then I would just basically copy my shape. I just figured out, I remember 1 over, 1 down, and then I would just, boom, go like this. And you can see how crappy I draw it. You can draw it crappy too. Just get those 3 points in there. These 3 points are key. If you can get those in there, you're good to go. So that's really it. That's why I'm not spending too much time on this. Y'all done this before. You just recall and connect it to past lessons. So let's go ahead and do it. This one right here, let's see. It's the same shape. You can see that it has moved over 2 times. It has moved over 2 times. So that means it has gone to the right 2 times. Right 2. So how do I write that? Well, I know that left and right movement is dealing with the interior next to the x. So it went right 2. We know it lies, so we're going to put that. Did this point go up or down at all? It did not. So that's our answer right there. Pretty straightforward. The domain for these and the range for these are always going to be all real numbers, which is negative infinity to positive infinity. negative infinity to positive infinity. So you can, of course, memorize it, but you could also read it and understand it. It's not that difficult. And I think most of y'all are picking it up now. Transformations for this one. Check it out. This thing is going up 3. It has gone up 3. So I'm going to go ahead and write my domain because I know what that is, y'all. It's going to be this for the same thing, domain and range, yada, yada. Let me fill that out. Up 3. So that is not attached to the x. So this will have x cubed plus 3. And that one doesn't lie. All right. Let's go on to the next. Not any questions. Duh, it's not class. If you have any questions about this, push pause and watch it again. And if you still need help, just come find me. All right, next. Okay, this one is talking about reflections over the x-axis versus the y-axis. So whenever it's really bizarre, you can see it. Whenever the negative is not connected to a parentheses, I'll show you the difference. This one actually looks like this. That's what that actually is versus this one right here, because they kind of look the same, but they're not. This is saying you're going to cube the negative. This one is saying you're not going to cube the negative. So it flips over the x-axis. So when it flips over the x-axis, this one right here, our original shape, I'm going to draw my original shape in black. Again, I'm going to draw my original shape in black. The original shape looks like this. And then you just basically like curve, I forget. Oh, hold on one second. Sorry, I didn't want to draw it wrong, but it's basically like you do this. And you're just going on forever, right? And you yoink, make sure it passes that point. Doesn't have to be perfect. That's the original equation. And it's centered around here. And now what happens is I'm going to do it in blue for the reflection. The reflection over the x-axis, meaning you are going to fold this over the x-axis. So this part's going to come down and this part's going to go up. So what does that look like? We're starting here, and then it's going to look like this. So that is what a reflection over the x-axis looks like. It's kind of the same thing. One second. Okay, here's the cool part about the way this shape is. If you notice, if you folded it over the x-axis, you see how it's basically the same shape. But if you fold it over the y-axis, it's going to be the same shape as well, too. So I'm going to draw the original shape in black right here as well. The original shape looks like this. We're going to do it down like that, and then it's going to come over like that. That's the original shape on this one. And then what ends up happening is for our numbers, we're going to show you. When this flips over, right here that says flip over the y-axis, it's basically the same thing. And it's because of the rotational symmetry. If it has rotational symmetry, that means it's going to basically look the same when it flips over the x and the y, more or less. There might be exceptions, but that's it. So what are the points we plugged in here? We plugged in 0, we plugged in 1, we plugged in -1, we plugged in 2, and we plugged in, let me put it in the correct order, 0, 1, 2, I'll do it this way. -2, -1, 0, 1, 2. These are the numbers we plugged in. I'm going to push pause and fill them in. All right, y'all, check out the x cubed numbers right here. I just filled them in so I wouldn't waste time on the chart. Notice the numbers, they're the same. So it's a product of rotational symmetry that, like, if you do it over the x-axis, do it over the y-axis, it'll be the same reflection. So I thought that was kind of cool. So I wanted you to see that. This is the number of things when you plug in -2, -1, 0, 1, 2. This is the output function. The next thing are these weird transformation notations. I don't like these at all. I never have. These are not my favorite, so I don't care about this. I'm moving on. Again, these things only work in the context of whatever. Anyways, that's it for this lecture.